Welcome back. In this lecture, we're going to discuss histograms. Let's first understand what a regular histogram is, and then we'll explain what an image histogram means. In general, a normal histogram is just a visual representation of the distribution of a continuous feature. So here's a simple example that has really nothing to do with images, but on the x-axis, we have some sort of continuous feature. In this case, it's how tall these trees are in height. So then we have these bins, and on the vertical axis, we have frequency. So basically the way you actually read this is, you have 3 trees that are between the heights of 60 and 65, as well as 3 trees that are between the heights of 65 and 70. And then that third bin, counting from the left, between 70 and 75, it looks like it marks about 8. So then you have 8 trees that are between 70 and 75 feet. Now you can also then display this as a general trend by drawing what's known as a kernel density estimation plot. So instead of having those bins, instead what you can do is just draw a line that basically reflects the frequency distribution of whatever x-axis you're trying to understand. Now for images, what we can do is we can display the frequency of values for colors. Each of the 3 red, green, and blue channels has values between 0 and 255. What we can do then is plot these as 3 histograms on top of each other to see how much of each actual color channel there is in an actual image. So here's an example histogram. In fact, this is the histogram for that blue bricks image that we were working with during the smoothing and blurring. So what is commonly done is for each particular color, you just color in the histogram. So we can see here that we have in general lower values of red, and it seems like we have higher values of green and blue. And it looks like they all peak around somewhere maybe a little close to 225. Now recall that 0 means pure black. So if you have an image of a lot of black, you would expect to see a lot of peaks in the black, or peaks near 0, I should say. Let's explore how to create image histograms with Matplotlib and OpenCV. All right, let's begin. I've already imported CV2, NumPy, and Matplotlib. What I will do now is import 3 images. And in fact, I'm just going to copy and paste the import commands from the notebook. That way we don't just waste time doing the same lines of code over and over again. But basically what we're doing here is I'm going to import an image of a horse, an image of a rainbow that we've already seen before, and an image of those blue bricks. And note, for all of them, I'm converting the color to be correct for Matplotlib. So I'm actually doing 2 variables. One is called dark horse here, and the other one is called show horse. This one's called rainbow, and the other one is show rainbow. This one's called blue bricks, and the other one's show bricks. The reason I'm creating 2 variables for each particular image is because one of them I'm actually going to perform my calculations on. Because we're going to be using OpenCV to perform calculations of color histograms, we should have it in the RGB color order, or BGR color order, that OpenCV expects. If we actually want to show the image though, so we can relate the histogram to what we're seeing visually, then we'll have this show horse image, or show rainbow, or show bricks, and that one is color corrected for Matplotlib. Again, here we're using the original blue GR channeling for OpenCV, and then on the show ones, these are converted to RGB for show. So we're going to keep the originals, that way we can perform calculations on it for the color histograms, since we'll be using OpenCV to actually perform those calculations. But let's just quickly show you what these images look like. So we'll do the show horse. So what's interesting about this horse picture is, notice there's a ton of black around this horse. So I would expect that a lot of the values are actually spiking near 0, since that's the representative color for black. So we don't see a whole lot of red, blue, or green when there's black there. Okay, so that's the show horse, show rainbow. So here we can see the rainbow. It looks like there's a pretty good distribution of colors. It looks like there's a little more red here, but that could be balanced out by the green and blue being shown over here on the bottom right. So rainbow's kind of interesting. And then let's see the blue bricks. And whoops, I showed the wrong one. We want show bricks. So that's the reason we have show, is to actually display the image. Blue bricks, the original, that's what we're going to be working with. And show bricks is essentially just blue on white. So I would expect to see really high values of blue, maybe some green, probably not so much in the red. Okay, so what do we actually do here to calculate the histogram values? And that function is simply CV2, and we say calc hist. Notice that the H is capitalized. Then as a list, you pass in the image you want to calculate for. So notice the brackets there. In this case, we'll do blue bricks. Notice I'm doing blue bricks, not show bricks. Showing was just for matplotlib. And then you decide what channels you want. In our case, let's go ahead and do the blue channel. So as a list, I'm going to pass in 0. The reason I'm doing 0 is because remember, for OpenCV, the color channel order is blue, green, red. So at index 0, the very first one, that will be blue. So right now I'm just interested in blue. So we'll say channels and then pass in blue there. Then there's an optional mask parameter. The mask parameter is if you want to apply a mask to only part of the image and only calculate the histogram for that part of the image. In our case, we want the whole image, so we'll say none. Then the other parameter is hist size. Histogram size, that essentially gives you the upper limit, so we can say 256. We want one more than the actual 255 limit. And in similar thinking, what we're going to do is say ranges is equal to, and we'll go from 0 to 256. Again, the reason we're going from 0 to 256 is it's essentially up to, but not including 256. So our values are from 0 to 255, so we want to add one more, so we don't cut off any values at 255. And let's save this. We're actually going to assign this to hist values. Run that, and let's check it out. Let's check out hist values. If we check out the shape of this, it's 256 by 1. So then what we're going to say is plt plot the hist values. Run that, and here we can see the histogram values for the blue color. Notice that it looks like we have a peak at around 150 for blue, and also a peak around maybe 225 for blue. Let's now actually try calculating the same coloring, but we'll do it now for this horse. So remember the horse, if we actually see the horse, there actually isn't that much color in this image. And there's certainly not a lot of blue color. This brown is probably more red than anything. So we shouldn't expect to see a lot of blue in this image because most of it is just black. And then the brown, it's very much contributing from red. So we shouldn't expect to see that much blue. Let's try it out. I'm going to copy and paste the same command. Place it down here, but instead of blue bricks, let's put in our dark horse. Run that, and we'll say plt.plot, and we'll plot out those hist values. Run that, and for the dark horse, notice what it looks like. Pretty much completely different. You now see that most of the values for the blue channel are actually pretty much 0, which makes sense because most of that image was black, which is 0, and the stuff that was colored in, such as the horse, that was mainly a kind of reddish brown, so I wouldn't expect to see that much blue. There's a little bit of a bump here, kind of close to 0, but that's basically probably its only contribution to the image. So I would expect to see most of this be 0. Okay, so now let's actually show you how you can plot out the 3 color histograms all at once. So we're going to come down here, and let's do this for the blue bricks image. We'll say image is blue bricks, so we're just going to reassign it there. And what I'm going to do is say color is equal to, and I'll say a string B for blue, string G for green, and then string R. Remember, this is the order that OpenCV does its color channeling in, blue, green, red. And then I will say for I, color, and enumerate, and all I'm going to do here is essentially call that histogram function 3 times, once for each color. We'll say enumerate color, we'll say hist R is equal to CV2, and then we're going to calculate the hist. We'll calculate the hist.image. Notice I'm passing it in as a list. And then the color channel we're going to be passing in is defined by I. I, because it's enumerate, is just going to be 0 on the blue, 1 on the green, and then 2 on the red. So that works out. And then there is no mask. We'll say none. And then we'll use the same values as before. 256. And the range is 0, 256. So now that we have that, we'll go ahead and plot it. We will say plt plot, hist R, and then we'll say color is equal to COL, essentially labeling it B, G, or R. And whoops, let's make sure this is, I'm going to change this right up here to be COL. That way you don't get confused with this particular color. So we'll say for I call, so short for color, and then assign it. So COL right here, that's going to be B, G, and R. Then we'll plot that out. And then we can set the X lim as well, just in case. This is just setting the X limits in case we get a very large histogram that extends beyond 256. So we're going to set those limits, and then outside of the for loop, we'll title this histogram for blue bricks. And let's run this. Okay, so here we have the histogram for blue bricks. And notice what we have here. We don't have a lot of contribution from red. We have a lot more contribution from green and blue. It makes sense because if we take a look at that actual bricks image, in fact, we can display it right here by just saying plt imshow, show bricks. We mainly have the colors blue. Okay, now let's see what happens if we do this exact same thing, but for the dark horse. So I'm going to say now for horse and change this image to be dark horse. So I rerun that cell, rerun this, and now I see the histogram for the horse, and pretty much for every color, it actually didn't have that much. Let's change the XLim so we can kind of zoom in here on what's going on between the values of 0 and 50. So I will change my X limits to 0 and 50, and I run that again. And let's actually now change the Y limits as well. So we'll go down to maybe 500,000. So this is a really large image. There's tons of counts here. And we can change that Y limit to say plt Y lim. In this case, we'll go from 0 to, let's say, 500,000. Run that, and now we can really see the bumps we have here. So it looks like red starts getting a bump around maybe a little beyond 10, and a little bit of green and bump, but really not that much. As we know, a value of 10 in RGB between 0 and 255, that's really not that much color. So a lot of that image is black, and because it's such a large image, that pixel count really distorts this histogram. So keep that in mind. If you have a really, really large image, and the horse image is quite large, you can check it out here. We can say dark horse shape. It's 1800 by 2700. So that means it's going to be 1800 by 2700 times 3. So we have, this many pixels in it, around 14.5 million. So that much of the image, especially that many dark pixels in pure black, that's going to distort your histogram. So just keep that in mind as you begin exploring color histograms. Okay, we'll stop part 1 here. Coming up next, we're going to discuss histogram equalization and finish off this section of the course. We'll see you at the next lecture.